Hello everyone, this is problem 6 of 30 in the 2022 Purple Comet Math Competition. Let's have a view of this problem. Let a sub 1 equal 2021, and for n greater than or equal to 1, let a sub n plus 1 equal root 4 plus an. Then a phi can be written as this combination of radicals where m and n are positive integers. We want to find 10n plus n. So, of course, the best way to do this is start listing from A1 to A5. A1 is 2021. A2 is equal to root 4 plus 2021. That's equal to root 2025. And then this is actually just equal to 45. This is a neat trick. So if you have like a two-digit number such as 35 and you want to square it, it's just 3 times 4, 12, and then add the 25. So we can use the same rule over here. 45, 4 times 5, 20, add the 25, 20, 25. Let's go to a sub 3. A sub 3 is equal to square root of 4 plus 45. So this is equal to square root of 49, which is equal to 7. And this is cool because the first 3 terms in the sequence are all integers given that we have square roots, which is kind of cool. So let's go to a sub 4. A sub 4, this is probably where we'll start getting into the irrational numbers. We have square root of 4 plus a sub 3. A sub 3 is 7. So this is equal to square root 11. And then a sub 5 is equal to square root of 4 plus a sub 4, which is square root 11. So this is ultimately what we want to express as this thing over here. So the best thing we can do here is squaring it. The reason being, squaring it, if we call this like a and we call this b, squaring it gives us a plus b, which conveniently becomes m. And the product is not too bad because m plus root n and m minus root n are conjugates. So we might just go with the multiplication, and I think I will use a separate sheet to just do that. So it's root n plus 2, I believe. Let me just check. M plus root n by 2, square root, okay, plus root n, m minus root n by 2, and I want to square this, so this thing squared. So this is equal to m plus root n over 2 plus m minus root n over 2, and then plus 2 root, m plus root n times m minus root n, they're just conjugates, so that becomes m squared minus n over 4. So if we were to just simplify that a little, m plus root n over 2 plus m minus root n over 2 becomes 2m over 2, which is m. And then this thing over here becomes, we have a square root of 4 in the denominator, which is just effectively 2. 2's cancel out, so we're just left with square root of m squared minus n. And now we can equate this to whatever here. So we're given that a sub 5 is equal to square root of 4 plus root 11, which is equal to this. So if we're going to square this, we have to square root 4 plus root 11, which is just 4 plus root 11. And then from here, it just becomes easy. We can pattern match. This is the rational part, this is the rational part, this is the real part, this is the real part. So real parts equate n is equal to 4. And then we have root 16 minus n is equal to 11, from which n is equal to 5. So I believe the problem wants us to find m is equal to 4, n is equal to 5. We want to find 10m plus n, that's just 10 times 4 plus 5, which is 45. And we are done.